Hello and welcome back. We are looking at the University of Helsinki's massive open online course. In the last video we looked at lists, a bit of an introduction to lists, and we're going to pick up where we left off today. So, my name's Duncan, let's get on. So, here's our next challenge, index out of bounds exception. A list is extremely useful for storing the values of variables for use later. That said, making mistakes is also relatively easy with a list. There is a program that uses a list in this exercise template. Modify it so its execution always produces the error index out of bounds. The user should not have to give any inputs to the program. You can also see a means for going through the values of a list. We will return to this a bit later. Okay, let's have a look. So let's just try to get the position 6. Oops, got a typo, let's get rid of that. There we go. So if we run that now, it should get, we should definitely get an error. So test it against the server. There we go, so we've got that one passed. So remember again, we've got the list, which starts at 0. So if I just put these at the front of the lines, just to show you why 6, just if you're not quite sure on the concept of lists. So this one would be 1, 2, 3, 4 and 5. So because we're asking the get method to find something at position 6, it can't, so the index is out of bounds. Okay, so just undo that. Brilliant, and we'll get that one closed and we will have a look at the next one. Okay. A place in a list is called an index. Numbering places, indexing always begins with 0. The list's first value is located at 0 and the second at 1. The third value are indexed 2 and so on. In programs, an index is denoted with a variable called I. In the list above, the first value is 6 and the second value 1. If a new value was added to the list by calling the add method of numbers with 8 as a parameter, the number would be placed at index 6. And it would be the 7th number in the list. Okay, so they're just adding basically on to the end of the list. You can insert in specific places and replace values, but just the simple add just adds it on to the next position in the list or the next index in the list. Similarly, by calling the get method with the parameter 4, the 5th number in the list would be retrieved. So we've got 1, 2, 3, 4. By calling the method get with the parameter 4, the 5th number in the list would be retrieved. So in this example, we're actually passing a number. So imagine the get method that we were looking at just a moment ago was 6, but we would say get 4, and then that would give us this number, which is the 5th one in the list because it starts at 0. Okay, so here's an example. So we've got Madeline, Mike, and Lawrence. What is the index of string Madeline? So that should be 0. There we go. Importing multiple pre-made Java tools into the program. Each tool offered by Java has a name and location. The program can use a tool after it has been imported with the import command. The command is given the location and the name of the desired class. For example, the use of an array list necessitates placing the command import java.util.arraylist to the top of the program. The same is generally true for all Java classes. We've been using the scanner class for reading input by importing the java.util.scanner. Bringing of multiple tools to use is straightforward. The tools to be imported are simply listed at the top of the program. So just as we were looking at before, you can write them yourself, or when you try to import the class, so if you try to import the scanner class or the ArrayList class, you'll get your 2 red underlines, and then you can insert the import automatically that way. So iterating over a list. Iteration means to loop through a list or read through a list. We'll next be explaining methods that can be used to go through the values on a list. Let's start with a simple example where we print a list containing 4 values. So here's our list. Our list is called teachers, and then we're adding the teacher names, and then here we're printing out the 4 teacher names. The example above is obviously a bit clumsy. What if there were more values on the list, or fewer? What if we didn't know the number of values on the list? The number of values on the list is provided by the listSize method, which returns the number of elements on the list. The number is an integer and it can be used as part of an expression or stored in an integer variable for later use. So here we've got our list, and here we have our method listSize. So at the moment there's nothing in the list, so it's set to 0. Then we add our first item, it's set to 1, and then we add another item, and then for some reason we're not printing out listSize, but it would have updated to 2. In the next exercise template is a program that reads input from the user. Modify its working so that when the program quits reading, the program prints the number of values on the list. Okay? So this one's called listSize. So this is our loop that is going to keep looping through. It will break with an enter, or a plain enter with no text passed. So what we can do is print out the list size. So we can do list.getSize. Oh, it's not getSize, is it? It's .size. There we go. And that will print it. You could do it a different way. You could create an integer called listSize, or whatever you really want to call it. And then we could say that listSize is equal to list dot, I don't know why I keep trying to type getSize. There we go. And then we could print out the variable listSize like this. So there's a few different ways that you can do it, and they're all fine. They're all good ways to use. So let's give that a test and see how we did. And there we go, another one done. Oh, there we go. Cool. Right, let's see what the next one is. Iterating over a list continued. Oh, so consequently, was it this one? Oh, this bit here. So if you, for this size, this is fine. But if you had like 100 or 1,000 items in your list, this would be a terrible way to print your list out. So hopefully they're going to show us a nice little method to iterate over some lists. Let's make a new version of the program that prints each index manually. In this intermediate version, we can use the index variable to keep track of the place that is to be outputted. So there we go, we've got our 4 items to be added to the list. And then what we're doing here, so we've got index is less than teachers.size, teachers.getIndex, index equals index plus 1. So they're looking at the array list element, so index plus 1 is basically 0 plus 1, 1 plus 1. So remember, this one is 0, this one is 2, 3 and 4. So they're looking to print the appropriate item from the list using the index. So normally we would use I here. And then they're doing that loop for each of them. So this is still not really much of a better way. We can see that there's repetition in the program above. We can convert the if statements to a while loop that is repeated until the condition of index is less than teachers.size no longer holds, i.e. the value of the variable index grows too great. So here we go, we've got one loop now. So while index is less than teachers.size, systemout.print the teacher at the position, so 0, 1, 2, 3, 4, and then we're updating our index and then going through the loop again. Now the printing works regardless of the number of elements. The for loop we inspected earlier, used to iterate over a known number of elements, is extremely handy. We can convert the loop above to a for loop, after which the program looks like this. So again, this is very similar to the while loop, just that the conditional logic is in a slightly different position. So we've got index equals 0, index less than teachers.size, it will print this out, then it will do I++, so it will add 1 to the index and print each of the teachers out in turn. So the for loop is a good one. Earlier we saw a for each loop, and hopefully they'll be getting to that one as well, because that's a really good loop as well. The index variable of the for loop is typically labelled I, and typically it starts at 0. Obviously for an index it needs to start at 0, but if you've started yours at 1, you might get some funny results, so maybe just double check that you've definitely started at 0. Let's consider using a list to store integers. The functionality is largely the same as in the previous example. The greatest difference has to do with the initialization of the list. The type of value to be stored is defined as integer, and the value to be printed is stored in a variable called number before printing it out. So here we go, we've got our numbers 1, 2, 3 and 4, and then we're basically printing out the numbers here. Printing the numbers in the list in reverse order would also be straightforward. So this is going to work backwards. So int index equals numbers.size minus 1, while index is greater than or equal to 0, int number equals numbers.getIndex, system.out.print number, and then index minus 0. So they're starting with the size of the index but minus 1, so that they get the positions, and then they're printing out each of those positions in turn. So remember, this first one, or this last one, sorry, would actually be 3. So that's why they're minusing 1. The size is 4, but we need to minus 1 because that one's 3, 2, 1 and 0. Hopefully that made sense. The execution of the program is visualized below. However, the visualization does not show the internal state of the array list, so the values contained by it. So let's have a look at this one. So that's not an especially great example, but did you notice here index 3 and is printing number 4? So remember, the list size is 4, we minus the 1, that gives us the 3, and at position 3 is number 4. So remember, this line is 0, sorry, this line is 0, this line is 1, 2 and 3. Okay, so as we click through that, you'll be able to see the index going down and the number going down as well. There we go. So the next exercises are meant for learning to use lists and indices. Even if you could complete the exercises without a list, concentrate on training to use it. The functionality in the exercises is to be implemented after reading the input numbers. So in the exercise template, there is a program that reads inputs from the user and adds them to a list. Reading is stopped once the user enters an empty string. Your task is to modify the method to print the last read value after it stops reading. Print the value that was read last from the list. Use the method that tells the size of the list to help you. Okay, so we can use our list.size minus 1, and that will always give us the last element. So let's head over to our NetBeans, give this a close, and open last in the list. Okay, so this is our while loop. So this is the end of the while loop. You can see that the open and close highlight. So let's just write here that this is end of while loop. And then what we need to do is print the last item in the while loop. Sorry, in the list from the while loop. So what we can do is, so we do system.out.print list.get, oh, they're not, yeah, they have called it list, and then do list.size minus, what happened there, list.size minus 1. There we go. So this is a bit of a shorthand way of writing it out. So we can declare some integers. So we could say list size and say that is equal to list.size. And there we go. So we've got our integer there. And then what we're doing is index to print. So I just is equal to list size minus 1. So for example here, the position might be 4, but because it's a 4 size list, it will only print out up to 3. So just for example. So we've got our list size, we've got our index to print, and then we would use list.get index to print. So we'd do list.get index to print, so that would always give us the last number. But like I've sort of demonstrated here, you can write it all in one line. So what we've got, I'll delete this and I'll do it, whoops, delete this one and I'll go through it again. So we've got list.get, and we've got our quote parentheses. We need to print it from a certain position, so we know that it's going to be list.size -1. Okay, so we've just cut out the variables because in essence this method returns an integer, so that is fine to use it like this. So let's give this a little run and see what we get back. And there we go, another one done. Let's okay that one. Oh, need to refresh. So, first and last, in the exercise template there was a program that reads inputs from the user and adds them to a list. Reading is stopped once the user enters an empty string. Modify the program to print both the first and the last values after reading the ends. You may suppose that there are at least 2 values in the list. That's fine, so basically we don't need to worry about index out of bounds, so that's good. So let's head back over here, close this one, and get this one open. So what have we got? So we've got our while loop, that's the end of our while loop. You don't need to put the comments on if you're happy and you understand where the ends of the methods and while loops and things are. You don't need to put the comments on. It's just if it makes it a bit easier for you to visualize it. So we need to print the first element of the list. So we can just do a system out, and then we can do list.get, and then remember we can put the list.size inside the method. In fact, we don't even need to do that. We'll just print list position 0, won't we? So for the next one, where we need the last element, we can do list.size, and then we can do -1. Oh, why did that not like that? Oh, I put the -1 in the wrong place. There we go. Cool. Let's give that a run and see how we did. And there we go, another one done. So let's give that one a little refresh. These are quite nice intros into working with lists. It's quite nice exercises. Okay, so remember these numbers. The exercise template contains a base that reads numbers from the user and adds them to a list. Reading is stopped once the user enters -1. Expand the functionality of the program so that after reading the numbers, it prints all the numbers received from the user. The number used to indicate stopping should not be printed. Okay, that's great. Let's head to our NetBeans, close this one down, and open this one. Oh. Okay, so we've got our while loop. Oh, that's the end of the if, isn't it? It's not the end of the while. Might as well put it there now that I've started writing it. That's the end of the while loop. And then we've got that. So what we need to do is so we're going to need a integer to store a temporary store our count in. So we can do int count equals 0, and then put a semicolon on. If that's fine. So what we can then do is update count with plus equals Luku. I wonder why it's called Luku. There we go. Okay, so let's give that a little run. I think we might have to put something in to say if it's not -1, add them up. So we could do 2 ifs. The one that is already there, and then the one that we put in as well. Okay, so let's do 5, 6, and -1. Oh, we didn't put anything in to print it out. Silly me. Ah, right, so in that case, if it needs to print out, we will need to initialize the variable outside of the loop, because otherwise the variable will be within the scope of the loop and we won't be able to print it out. Let's put this if statement in anyway. So if Luku is equal to -1, oh, Luke, then what we'll do is put that in here, sort that out. There we go. Okay. Oh, and then we need the system out, don't we? So system out count. Let's just send that off and test it against the server and see what we get back. Oh dear, we've got a fail. Oh, we forgot to... Oh no, I did do the equal to -1, didn't I? Oh, it was meant to be if it does not equal -1. So if it doesn't equal -1, we need to update the variable, don't we? Silly me. Okay, we have got another error. That is not a problem. Let's have a look at this and see what we can figure out. Do you know what? I've been looking at this the wrong way. It's meant to be using the list, isn't it? So let me think. So if that's the end of the if the if is here, that's fine because that's going to catch the -1. So we don't actually need to add anything in. So if it goes through this loop, it's obviously not -1, in which case number.add will give us what we need. So we can get rid of count. And what we're going to do is, we could use a for loop. So for integer, so we can call in our integer I in numbers. So for I in numbers, s out number. I. Okay, let's give that one a test and see how we go. There we go. Excellent, so that one's done. Let's give that a close. And let's head back to to here, yep. Make sure we got that. There we go. The exercise, expand the program to ask for a start and end indices once it has finished asking for the numbers. Once it's finished asking for the numbers. Expand the program to ask for a start and end indice once it has finished asking for numbers. After this, the program shall print all the numbers in the list that fall in the specified range between the indices given by the users, inclusive. So it needs to do the numbers specified. You may assume that the user gives indices that match some numbers on the list. Okay, so if we print 1 and 2, of course, right, so this obviously is 0, then we're printing 1 and 2 here, so 1 and 2. Okay, and then in this one, so 0 to 2 prints 0, 1 and 2. So let's head back here. Okay, so there were specifics, weren't there? So it was from where and to where. So you can do an s out from where. So that's going to be int start. So we can say that that is equal to scanner.next int. And then we're going to need to know the end, so to where. That's going to need to be stored. And then we could use another for loop to print out. So what we can say is that I, so the start of the loop is going to be equal to the start number. And while I is less than or equal to, because it is inclusive, we can do that. So I will be equal to the start number, and while I is less than the end number, we'll print this code and then we'll add 1 to I, and it will keep looping round until I is equal to the end number. And what we're going to do is systemout.print numbers.get, and then in between our parentheses we're going to print out I. Okay, let's give that a run. Excellent, so that one is done. So let's close that one. And head back here, do our little refresh. Okay, so this one's going to be a comparison exercise. So continue developing the program so it finds the greatest number in the list and prints its value after reading all the numbers. The programming should work in the following manner. So we've got a list and it's going to sort through the list and find the greatest number. So let's head back here. Okay, so this is the end of our while again. This is going to be our system out. Okay, so I'm going to get... Oh, I'm not going to keep that for now. So what we could do is the for loop. So for int I is equal to 0, I is going to be less than list.size, so we're going to need to go through the list and figure out which one is the greatest. And then we are going to say, so we're going to need, right, so we need the greatest number, so int greatest, we could just equal it to get 0, and then that way it's already got one number that it compares. So what I'm thinking is if we create another integer and then pass that one I, so whichever number we're looping through, then we can use a comparison. So we can say if greatest is less than number, then we can say number equals greatest. Greatest equals number equals number. And then if we just double check what the printout was, so let's head back here, greatest number. Okay, so we need that, so we'll paste that in between these quote marks here, put a space, put a plus, and then we're going to add in greatest. So let's give that one a run. And there we go, another one done. Excellent. So let's close this one down. Oops. And then we'll head back here, do a little refresh. Actually, I just wonder if they would have done that one any different. Oh, we have to log in, don't we? We won't do that. So, index of. Expand the program by adding a functionality that asks the user for a number and reports that number's index in the list. If the number is not found, the program should not print anything. Okay. Okay. Right, let's head back here. And then get that one open. Okay, so what are we going to need to do? Right, let's open our program here. So we need some prompts, don't we? So let's get that. So we need this prompt, search for, and index is at 2. So I'll just copy both of those and then head back to NetBeans. So I'll put those there, select both lines, press Control and forward to get them both commented out. So we're going to need this in there. So then when we've got that, we're going to need to store the result in an integer. So int search is equal to scanner.nextInt. Remember, you can do it the other way as well. So you could do it scanner equals dot integer dot value of int I, and then pass the scanner, scanner dot next I. If you want, you could do it that way, but I think it's a bit long-winded. Right, so we've got that. We can use another loop. So what we can do with the loop is get the user input to be checked against each number in the list. If there's a match, print out the match. If there's not, it will just go through the loop and end the program. So we can do for int is equal to I is equal to 0, sorry. I is going to be less than list size, because we needed to go through the entire list. So less than list dot size, oh my days, size, and then we can do I++, and we are going to use a simple if statement. So, oops, forgot the semicolon, the parentheses. So if search is equal to list.get I, so the ith position, we can do system out. Let's see. I got the thing, didn't I? Here. So we'll need that, and then what we're going to do is do search, because that's going to be the search number, plus is at index space, and then I, and then let's have a look at this. What have I got wrong there? Incompatible types, int can't be converted to boolean. Oh, it's because I only did one equals. Here we go. Okay, that looks good. Let's give that a run. Excellent, another one passed. So let's close this one. Head back here, do a little refresh, and then we're on to the next one. So index of the smallest, or smallest. Write a program that reads numbers from the user. When 9999 is entered, the read-in process stops. After this, the program will print the smallest number in the list, and also the indices where that number is found. Notice the smallest number can appear multiple times in the list. Okay, so do we have a one where it appears more than once? Oh, okay, so it's going, oh, right. Okay, so we need to print both positions. Oh, that'd be interesting. Okay, let's go back to our NetBeans. Let's get that one open. Oh, wow, okay, we haven't got anything really this time, have we? We don't even have our array list. So let's do array list, integer list equals new array list, and then we're going to need the while loop, aren't we? So while, and then we had true, we're going to need an integer, call it in, is equal to scanner.nextInt. Then we're going to need the breakout option. So if in is equal to 4 nines, we will break. If it doesn't meet that, then we need to add the number, the inputted number, to the list. That's the end of our while loop. End of while. So last time we had an integer for the greatest when we worked out the greatest. So if we do int smallest is equal to list.get 0, then we'll need a for loop for our comparison. So int I is equal to 0, I is going to be less than, the list size. I++. Get rid of this. Actually, I'll keep some of that. So if small is equal to list.get I, no, I've done a single thing again, equal sign. System out. Oh, what was the thingy? Found out. Oh. And then index I. So that should do it. So hopefully that will. Yeah, so this will keep going through the list, irrespective of if it finds the smallest number or not. Well, it'll need to go through the whole list to find out what the smallest number is. So if it finds a small number, I wonder if that needs to be less than or equal to. No, it doesn't. Of course it doesn't. So if the small is equal to that number, so if it finds it at one position and then another, it will print both of those positions out. So let's give that a run. Oh, we didn't get that one first time. Let's have a look. The smallest number should be printed in the format smallest number 2, where 2 is the smallest number. Oh, I forgot the S out. Let's just double check that. Smallest number is 2. So that is going to need to go outside of the loop. And then that's going to be plus small. Okay, let's give that one a run. I don't know if I'd mentioned, I think I might have paused recording at the wrong time. I got an error because I forgot to put this line in. So when we head back to, in fact I'll just quickly show you. So here, oh, there, I copied that and put that in, and then changed that. Oh, I've still got an error. Exercise failed. Let's have a look at the tests. That doesn't really help, does it? Okay. Let's give it a run locally and see what we find out. So, 2. Oh, that's odd. Smallest number is 2, found at index 0. Let's run it again and put a couple of 2's in. Found at index 0 and 6. Let's just move this over. Oh! 2 is at index. Oh, I wrote the wrong string. Silly me. So actually, I need to put that in, and then it was like that, wasn't it? I think. Should probably have checked before I ran it. Oh my days, I'm not doing very well at all. Okay. Let's just pull these both up side by side again. Am I looking at the right one? Oh, I'm looking at the wrong one. Smallest number. Oh, it is found at index. Okay, let's put that back in. Ah, wonder if it's because I missed off the semicolon. So we've got smallest number, semicolon with a space. That's good. We don't want that space. So let's give that a run. Seems that I've got a bit of code blindness. Let's. What I'm going to do is I'll pause the video. I'll figure out where I went wrong, and then I'll show you. rather than you having to go through every single one of my errors. I think 3 mistakes is probably enough for you guys. Bear with me and I'll figure out where I went wrong. I know what I've done. I haven't put the update in for the variable. So if small, yeah, I need to put the variable update. So what have we got? We've got where's that gonna go? I haven't put the whole blooming thing in. I need a loop to figure out which one the smallest is. Right, so let's think. It's gonna have to go after this int, but before this. So we will say if int I equals 0. Oh, I hate it when it's not spaced properly. I is less than list dot size I plus plus. Why did that close off there? What have I done? This is all going horribly wrong. Int I is equal to 0. Oh. 4. So int small is going to be equal to list.get I, and then we need our if. So if small is less than number, we haven't put the number in, we'll call it num is equal to small. Oh, that needs a double equals. That needs to be initialized. What have I done now? Variable small is already defined in the method. Oh, of course it is. There we go. Now what? Oh, not a statement. There we go. So for int I is equal to 0, I is less than the list size, check this, I plus plus, okay. This is like 4th time lucky. Good heavens, this is not going well. Right, I'll go back to figuring out where I've gone wrong, and then I'll unpause again. Well, that shouldn't be small, that should be num. So if small, so small that is less than num. Excellent, finally passed it. Right, so I basically had totally messed up my if statement. This one. I had this back to front, that was the wrong variable name. So I sorted that out and we got the pass. So let's close this one down. Hopefully some of you were staring at the screen, screaming at it, thinking, knowing where I'd gone wrong. And that is a good thing. Alright. Okay, so iterating over a list with a for each loop. I thought we looked at for each loop, but okay. So you don't need to keep track, if you don't need to keep track of the index as you're going through a list's values, you can make use of a for each loop. It differs from the previous loops in that it has no separate condition for repeating or incrementing. So what we've got here is our variable that's been, our list that's been populated with these 4 names. And what this is saying is for each string in teachers, system out print teacher. So imagine this is our int I equals 0, semicolon I is less than list size, but there's no I++, there's no increment, because it's a for each. So for each item in the list, it will run this loop. They're really good little lists, good little search functions and loops. They're really good things to use. In practical terms, the for each loop described above hides some of the parts of the for loop we practiced earlier. The for each loop would look like this if implemented as a for loop. Funnily enough, we've just been through that. So it's exactly the same. So this is the bit that is this section would be string teacher. This section would be the size, We don't have an I++, and it would print out pretty much the same thing. It's very similar to how a while loop is very similar to a for loop as well, but just in a slightly different order. In practice, the for each loop examines the values of the list in order one at a time. The expression is defined in the following format. So for type of variable, name of variable, in the list or name of list, where type of variable is the list's element type, and the name of variable is the variable used to store each value in the list as we go through it. So let's go back here. So we've got for type of variable, string, name of variable, teacher. So this is, like I said, this is our int I equals 0. Okay, so string teacher, and then name of list is teachers, because that's the name of the list here. Okay, so here, oh, it's the same, this example. So we're adding the bits to the list, and then it's going to start looping through. So it's going to start finding the different names and printing them out. There we go. So I'm going to stop this one here. So as always, thank you very much for joining me today. Good luck and happy coding.